Hey everyone, and welcome to this deep dive. We're going to get into some serious API security today. It's kind of like, when you're having a party and you only want your real friends to get in. You got to have some kind of system to keep the randoms out, right? Well, that's what we're looking at today. How to build a custom AWS Lambda authorizer. It's like a digital bouncer for your API routes. We're going to be using 2 Medium articles by developer Vinayak Nigam, so we've got some real-world experience to draw on here. All right, so first things first, what is a custom Lambda authorizer? How does this thing even work?
It's all about control, really. You get to decide who gets access to your APIs and what they can do once they're in. Like setting up your own personalized security checkpoints. You've got 2 main types, token-based and request-based. Token-based is, simple like checking an ID card at the door. Request-based, it's more like a detail-oriented bouncer, you know what I mean? They check everything, headers, query strings, even location data sometimes, to decide if you're actually on the list.
Gotcha. Different levels of security for different situations. So what are the trade-offs between those 2 approaches?
Well, token-based is generally faster and easier to set up. Request-based is more flexible for when you need really, really specific access control. Early in my career, I actually I spent way too long trying to debug a request-based authorizer because I thought it was token-based.
A good reminder that everyone makes mistakes, even the experts, right? But hey, that's how we learn. So let's focus on how all this works with Auth. What's the Lambda function actually doing in that scenario?
Basically, it's verifying that any token someone tries to use is legit, like making sure a passport is real and not some kind of clever forgery, right?
So it's not just letting anyone with any token through. Auth has to vouch for them.
Exactly. Now, what's great is a custom function like this is super flexible. You can add more security stuff later on as your needs change.
Okay, that's cool. So walk me through the process. How does a Lambda function actually check someone's access?
All right, so picture this. The request comes into your API gateway, and your Lambda function, it springs into action. First, it checks for the authorization header, which has the token.
Right, like checking for the invitation before you even open the door.
Yeah, exactly. And then the investigation begins. The function checks if the token's even legit, if it's still valid, making sure it hasn't been messed with. If everything looks good, it creates what's called an IAM policy. It's basically like a set of permissions, that determine what the person can actually do.
Now, for those of us who need a refresher, what exactly is an IAM policy?
So IAM stands for Identity and Access Management. And their policies are like rule books for your AWS environment. They're written in JSON. And they basically define who can access what and what actions they can take, like reading data or even running other Lambda functions. Our author actually, they really emphasize logging all of this stuff to AWS CloudWatch.
Good old debugging. Always helps to have a record if something goes wrong, right?
Absolutely. A little pro tip, create separate authorizers for each API route, even if they're all handled by the same Lambda function. It'll make your life so much easier later on, trust me.
I'm all about making things easier. So let's switch gears a bit and talk about the front end. Our author had a real journey figuring out how to securely handle those access tokens from the front end.
Right, because you can have the most secure backend in the world, but if your front end's linking tokens, you're still in trouble.
Yeah, big time. And this is where things got interesting.
The usual way is to just attach the access token to the authorization header when you're making requests from the front end. Pretty straightforward.
Seems easy enough, but I have a feeling there's a but coming.
You know it. So our author, they tried this with a simple Vite setup at first, but they realized that the access token, it was just sitting there.
Yeah.
Visible in the browser's network tab.
Oh, yikes.
Yeah, not good. Anyone snooping around could just grab that token.
So what did they do?
They made a big decision. They decided to switch from that basic front end to a full stack framework Next.js.
Wow, okay. Big change.
It was, yeah. But it let them handle that token stuff on the server side, away from prying eyes in the browser.
Makes sense. Much more secure.
They also decided to use Next.js App Router, which is a newer way to build Next.js apps. But it's got its own learning curve, for sure.
I bet. We might need a whole separate deep dive just for that. But for now, let's stick with those tokens. What exactly are JWTs, and why are they so important?
JWTs, just some web tokens, are basically like digital passports, compact packages of information, digitally signed. They're used to securely send data between different parties.
Okay, I like that analogy. So like a Passport or JWT has different parts.
Exactly. You've got the header, the payload, and the signature. The header's like the passport photo. It tells you what kind of token it is. The payload is the info page with the actual data, like stuff about the user, the token's expiration date, things like that. And the signature is like the official stamp, guaranteeing it's authentic.
That makes a lot more sense now. And I remember there being different types of tokens too, right?
You got it. ID tokens and access tokens.
Yeah.
ID tokens prove who you are, like confirming your citizenship. Access tokens are about what you're allowed to do, like a visa that lets you enter a specific country.
Okay, so ID is about identity and access is about permissions.
Got it.
Right.
Our author actually had a pretty stressful experience with those, with Auth0's limits on machine-to-machine tokens. M2M tokens, I think they're called.
Oh, yeah, I read about that. They hit the limit because they were creating a whole new M2M token for every single API request. Their app basically crashed until they figured out how to properly cache and reuse those tokens. Classic case of read the documentation carefully, right?
Yep. A valuable lesson for all of us. Speaking of caching, our author talked about how it can improve both efficiency and security. How does that work with something as sensitive as tokens? Caching can be a bit of a double-edged sword, honestly. It speeds things up by storing tokens so you don't have to fetch them all the time. But if you're not careful, it can also create a big target for attackers.
Right, because if someone gets access to your cache tokens, they could do a lot of damage.
Exactly. So encryption is super important here. Our author decided to use Redis, which is a fast data store, and they added encryption to make sure those cache tokens stay protected.
Okay, so Redis with encryption, got it. How did they actually set that up?
Their implementation is actually pretty clever. The code first checks the cache to see if there's a valid token already. If there is, great. If not, it gets a new one from Auth0, caches it, and then continues. And all of this happens behind a secure internal API endpoint, which adds another layer of protection.
So it's like a token vault, carefully guarding those precious access keys.
Precisely. It's a great example of smart design that improves both security and efficiency.
This has been really insightful. We've covered a lot: custom Lambda authorizers, the different types of tokens, and how to handle them securely on the front end.
And we've seen how important logging and caching are.
Absolutely. Before we move on to the next part, I want to leave you with a question. What other security things should we be thinking about when building APIs with Auth0 and custom Lambda authorizers?
Plenty to consider. We'll dive into some more advanced stuff in part 2, so stay tuned.
All right, welcome back to our deep dive into custom AWS Lambda authorizers. We're really getting into the details now. Before we get into anything new, you mentioned checking for token expiry earlier. Why is that so important?
Well, those access tokens, they have a limited lifespan. And there's a good reason for that. It helps prevent someone from, using a token if it falls into the wrong hands.
Right, makes sense. So what happens when a token expires? Does the user just, get kicked out?
Not necessarily. Our developers got a pretty neat trick. Their backend code, it automatically tries to fetch a new token from Auth0 if the old one's expired.
So it just happens in the background. The user probably doesn't even notice, right?
Exactly. It's all about that seamless experience. You don't want your users to constantly have to log in again just because their token timed out.
For sure. Speaking of user experience, you mentioned our developers switched to Next.js from that simple front-end setup to improve security. What was the main reason for that?
It all comes down to where that access token lives. In a basic setup, if you attach the token to the authorization header, it can be exposed in the browser, in the network tab.
Right, not good.
Yeah, it's like leaving your front door wide open. Next.js lets you handle all that sensitive stuff on the server away from prying eyes.
Like moving your valuables from a tent to a vault.
Exactly.
But switching frameworks mid-projects look like a big deal. Did our developer have any regrets?
Honestly, they seem to really embrace it, like an opportunity to learn some new stuff. They even went with the Next.js app router, which gives them more control. But it can be a little more complicated to use.
We might need another deep dive just for that one. You mentioned earlier about reading the documentation carefully. And our developer, they learned that the hard way with those M2M tokens. What exactly happened there?
So M2M tokens are machine-to-machine tokens. They're like special passes that let applications talk to each other without a user having to log in every time.
Okay, so what went wrong?
They were generating a brand new M2M token for every API request. It worked fine at first, but as the application grew, they hit Auth0's limit. The app basically stopped working.
That sounds Stressful. How did they fix it?
They finally read the documentation. Auth actually recommends reusing those M2M tokens whenever possible. So they implemented a caching system, and that solved the problem.
Right. Classic RTFM. So caching, you mentioned it can be tricky from a security perspective. What are some of the things we need to be careful about?
Yeah, you're right to be cautious. One of the biggest risks is unauthorized access to those cached tokens.
Makes sense. If someone gets those tokens, they could impersonate a real user, right?
Exactly. That's why encryption is so important. Our developer chose Redis for caching, which is a good choice. But even Redis needs to be configured securely.
So it's not just about the tool itself, it's about using it properly. What other security stuff should we keep in mind with caching?
Token validation is key. Even when you're grabbing a token from the cache, you still need to check it, make sure it hasn't been tampered with or expired.
Right, because cache data can get old.
Exactly. And try to minimize what you're actually caching. Only store what's absolutely necessary, set expiration times, and maybe even use a separate caching layer just for sensitive data. And of course, always audit your system regularly.
Great advice. So Redis with encryption, are there other options out there?
Definitely. Memcached is another popular one. It's known for its speed. And then there are managed services like Amazon Elasticache that offers both Memcached and Redis, and then cloud-specific options from Azure and Google.
Lots of choices. Now, I'm curious about those JWT claims you mentioned earlier. What are they exactly, and why are they important?
Think of them like the data points on that passport info page we talked about. They're statements inside the JWT that give you information about the user or the token.
Okay, like little pieces of info embedded in the token. What kind of information?
Could be anything, really. The user's name, their email address, their permissions, when the token expires, who issued the token, who it's meant for, all sorts of stuff.
So they provide context about the token and the user, but how do we actually use them?
Once you verify the JWT, you can decode it and access those claims. Most programming libraries for JWTs have functions to make that easy.
So, for example, if we wanted to check if a user has admin rights, we could look for a specific claim in the token.
Exactly. Claims give you really granular control. You can use them for role-based access, personalized experiences, even logging user actions with more detail.
Pretty powerful stuff. Now, you mentioned token replay attacks earlier. Can you remind me what those are again?
Imagine someone finds a key and uses it to unlock a door they're not supposed to. That's basically a token replay attack. An attacker gets a valid JWT and then reuses it to gain access.
Not good. How do we protect against that?
Keep those token lifetimes short. That limits the window of opportunity for an attacker.
Okay, shorter lifespans. Got it. Anything else?
You can use a nonce. It's like a unique random value that gets included in the JWT. The server can check for it when validating the token.
Like a secret code word if the server doesn't recognize it and knows something's up.
Exactly. And you can even store used nonces on the server. So any token with a duplicate nonce gets rejected. And for even more security, you can implement token revocation, which lets you invalidate a token before it naturally expires.
Like a kill switch. How do you actually implement that?
There are a few ways. You can blacklist tokens or use a revocation service. The goal is to make the token useless if it falls into the wrong hands.
Got it. So short lifetimes, nonces, and revocation. Anything else?
Always transmit tokens securely over HTTPS. That encrypts the token in transit.
Right, because sending sensitive data over an unencrypted connection is, not a good idea.
Exactly. Now let's talk about API Gateway.
Okay, yeah. How does that fit into all of this?
API Gateway is like the front door to your backend APIs. It handles routing, validation, and, of course, authorization. When you set up a custom authorizer for API Gateway, you're basically telling it to hand off the ID checking to your Lambda function.
So API Gateway is the gatekeeper, and our Lambda function is the security guard.
Perfect analogy. A request comes in, API Gateway checks if there's a custom authorizer.
Yeah.
If there is, it calls your Lambda function. The Lambda function checks the token, verifies it, checks any claims or permissions, and then either grants or denies access.
Wow, pretty thorough.
It is. And a big advantage is it keeps your authorization logic separate from your API code. Makes things much easier to manage.
Makes sense. You mentioned creating separate authorizers for each API route, even if they use the same Lambda function. Why is that?
It's all about organization and control. It lets you fine-tune the rules for different endpoints and makes troubleshooting way easier.
Separate authorizers, less headache. Got it.
Exactly. Now, let's talk about logging,
Always important.
especially with security. Our developer really recommends logging everything to AWS CloudWatch. It's like a detective's notebook for your application.
What should we be logging specifically?
All the important stuff. Request details, the token itself, its expiration time, any claims, the authorization decisions made by your Lambda function, and any errors that occur.
So we have a complete record if we need to investigate something.
Exactly. Helps you figure out why something was denied, who made a request, and so on.
Logging is our friend.
It is. So, to recap what we've covered so far,
Yeah, let's do a recap.
we've looked at how custom authorizers work, token verification, policy generation, secure token handling on the front end, the different token types, caching, JWT claims, token replay attacks, API gateway, and CloudWatch logging.
Wow, we've covered a lot.
We have. But there's still more to come. In the final part, we'll look at some even more advanced security stuff and some different authorization strategies.
Welcome back to the final part of our deep dive. Time to get into some seriously advanced security.
All right, let's talk rate limiting.
Okay, rate limiting. That sounds familiar. It's about, controlling how many requests an API can handle, right?
Exactly. It's like a bouncer at a busy nightclub. They got to keep things under control, make sure it doesn't get too crazy. Rate limiting does the same thing for your APIs.
Prevents them from getting overwhelmed, right? Whether it's real users or just bots causing trouble.
Exactly. Keeps your API responsive and reliable. Keeps your users happy, too.
Right. Nobody wants a slow app. So how do we actually do rate limiting? Do you just set a fixed number of requests per second or something?
You can, but it's often more nuanced than that. You can set limits per second, per minute, per hour. You can even have different limits for different clients or users.
So, you could give paying customers more requests than free users.
Exactly. You can even set different limits for different API endpoints.
Okay, so it's all about fine-tuning. Are there any, standard ways to do rate limiting algorithms or something?
There are a few popular ones. Token bucket is one.
Token bucket?
Yeah, imagine a bucket that slowly fills up with tokens. Each request uses up a token, and if the bucket's empty, the request gets denied.
Okay, so it allows for bursts, but within limit.
Exactly. There's also leaky bucket, which processes requests at a fixed rate. It smooths out traffic spikes, but can cause delays during bursts.
Got it. So token bucket for bursts, leaky bucket for steady flow. What about sliding window? You mentioned that earlier.
Sliding window tracks requests within a moving time window. It's more accurate, but harder to implement.
So the right algorithm depends on your specific app, right? Now, do AWS Lambda authorizers and API Gateway have built-in rate limiting?
They do. API Gateway has usage plans, which let you set rate limits and quotas. You can link those plans to specific API stages and even integrate with AWS Wave, which is their web application firewall.
Wow, so we've got API Gateway, Lambda authorizers, and Wave all working together. Any tips for, actually setting those limits?
It's a bit of a balancing act. You want to handle your normal traffic, but also block those attacks. Monitoring your API usage is key. CloudWatch can help you fine-tune those limits over time.
Right, monitor and adjust. Now, we've been talking a lot about JWTs and custom authorizers. Are there other ways to handle authorization?
Absolutely. JWTs are popular, but they're not the only way.
What else is there?
API keys are one option. They're simple, static keys that clients include in their requests. Easy to use, but not as secure as tokens because they don't expire.
Okay, so it's like a basic password?
Kind of. Then you've got Auth 2.0, which is a framework for delegating authentication. You can rely on someone like Google or Facebook to handle logins.
Instead of doing it yourself.
Exactly.
Right.
More complex to set up, but more flexible and secure. And then there's AWS Cognito, Amazon's own service for authentication. Integrates really well with other AWS stuff.
So many choices. It sounds like the best approach depends on your specific application, right?
Exactly.
This has been a really amazing deep dive. I feel like I've learned a ton about API security.
Glad to hear it.
Any final thoughts for our listeners?
Yeah, as APIs become more important, we have to be really careful about security. It's an ongoing thing. We have to keep learning and adapting. To stay ahead of those who are trying to break things, think about new threats, new trends, how to build really secure apps. It's something we all need to be thinking about.
Excellent advice. Thanks for being our guide through the security jungle.
My pleasure. Knowledge is power, right? The more we know, the better we can protect our stuff.
Absolutely. Thanks for joining us on this deep dive into API security. Stay curious, stay informed, and stay secure.